in this example, we're going to apply L'Hopital's rule to compute a limit which has the indeterminate form infinity over infinity. Okay, so this is the limit we're trying to compute. So the limit as x approaches pi over 2 from the left of the function 1 plus 2 secant x over 1 plus tangent x. Okay, so as usual, we check the limit first. So we check what happens as x approaches pi over 2 from the left. Okay, so as x approaches pi over 2 from the left, what happens to secant is the secant function will approach positive infinity. And then in the denominator, as x approaches pi over 2 to the left, tangent x will also approach positive infinity. Okay, so now this whole thing, because this part goes to positive infinity, if you add 1 it doesn't change it. Again, because this goes to positive infinity, if you add 1 it doesn't change it. So we see that this limit is of the form infinity over infinity. Okay, so now we can take the original limit and apply L'Hopital's rule. So we have the limit as x approaches pi over 2 from the left, 1 plus 2 secant x over 1 plus tangent x. So L'Hopital's rule says we take the derivative of the top and the bottom. So it becomes the limit as x approaches pi over 2 from the left. Derivative of 1 is 0, so we just take the derivative of this part. Derivative of secant is secant tangent. Derivative of tangent, derivative of 1 is 0, and then the derivative of tangent is secant squared x. And so now we can simplify this expression. So this secant cancels out with one of these secants. So we're left with tangent x over secant x. 2 tangent x over secant x. And if you try to evaluate this limit, you'll see that's infinity over infinity again. However, instead of applying L'Hopital's rule again, this expression can actually be simplified further, and so we can avoid using L'Hopital's rule again. Okay, so we can write tangent as sine over cosine. So this is 2 sine x over cosine x, and secant x is the same as 1 over cosine x. So we can simplify this expression so the cosines will actually cancel out. And so this is the limit as x approaches pi over 2 from the left of 2 times sine x. So now as x approaches pi over 2 from the left, so we plug in pi over 2 here. Sine of pi over 2 is 0. So this is just 2 times 0. And 2 times 0 is 0. So the value of this limit is equal to 0.